Hello, so we're talking about scatter plots and lines of fit. I can use a scatter plot to describe the relationship between two data sets. So the vocabulary we're going to be working with is negative association and correlation, no association, positive association and correlation, and a trend line. Okay, let's see, there we go. Example 1, understand association. Part A, what is the relationship between the hours after sunrise and the temperature as shown in the scatter plot? So let's analyze the scatter plot. We're looking at all those little data points. That's the scatter plot. And we're comparing, and the X is the hours after sunrise, and the Y is temperature. So after the sun rises, wherever this lovely warm weather is, right? Because it looks like we're starting somewhere around 58 and going up to somewhere around 71, 72, a little less. And so what's happening here, right? That's what we're comparing. We're understanding the association. Well, as the time goes up, right, after the day goes, because this is after sunrise, the temperature is increasing. So if you read the words, it says the temperature is generally increasing over time. As the number of hours after sunrise increases, so does the temperature. So this is the math part then. When Y values tend to increase as X values increase, the two data sets have a positive association. That's all. And then still more association, but now we're talking at the hours after sunset, so after the sun goes down. Well, remember at sunset it was about 71, and now we're going down to about, these are going up by twos, so about 58, right? So as time goes on, the temperature is going down. So that's what this is saying. The temperature is generally decreasing over time as the number of hours after sunset increases. As the hours increase, the temperature decreases. So the math, when the Y values tend to decrease as X values, I'm right here. As X values increase, the two data sets have a negative correlation. All right, cool. And that's that. And then understanding association, there's more things. What about the hours after sunset and the amount of rainfall? Well, guess what? They've got nothing in common. Look at that data set. Look at those plot points. They're all over the place. There's no general trend in the data. So they have no association. Okay? I want you to pause the video, look at the scatter plots, and describe the association you're seeing. So the first one, right? What would you say? Well, they're increasing, so it's a positive association. And then B, the scatter plots are all over. That means there's no association. I wrote correlation, but really it should be association. We didn't talk about correlation till now. Example 2, understand correlation. How can the relationship between the hours after sunrise, X, and the temperature, Y, be modeled? So it's actually identical to what we were just talking about. If it's a positive association, it's going to be a positive correlation. That's if they approximate a line. So sometimes it could be a positive association because it is increasing, but it's difficult to make a line of best fit. So what we're going to do here is I want you to draw a trend line that fits the data to determine whether a linear function can model the relationship. And the way this works is I want to draw a line. Like if I'm looking at my graph, I want to draw a line. Where are you? There you go. I want to draw a line that goes where it has at least half the data points above it and half below it. It doesn't mean that you need to be through points. Sometimes you're not at all. That's okay. So here's a line that has half above, half below, and move me. The scatter plot suggests a linear relationship. There's a positive correlation between the hours after sunrise and the temperature. I'm just reading. When data with a negative association are modeled by a line, that means there's a negative correlation. If the data do not have an association, then they cannot, that's that line here, right? That they cannot be modeled by a linear function. All right, so try it number 2. I want you to pause the video after I read it. How can the relationship between the hours after sunset, X, and the temperature, Y, be modeled? If the relationship is modeled with a linear function, describe the correlation between the two data sets. So we're looking here, that was our second example. So the scatter plot suggests a linear relationship with a negative correlation. I hope you pause the video. The relationship can be modeled by drawing a trend line that best fits the correlation of the data. So where would I draw that line, right? Probably somewhere in the middle of the data. So some above, some below, but it should be a straight line. It's not a curve. You're not creating a curve. A line is a line is a line. It's never curvy. No dips, no points, nothing. All right. So I wanted to underline that it's a negative correlation because it's going down, and that we would create that trend line. And that's what we're going to show you how to do right now. Example 3, write the equation of a trend line. So a trend line models the data in a scatter plot by showing the general direction of the data. A trend line fits the data as closely as possible. So we're looking at the year starting in 2000 and the number in thousands of, at the top, electric hybrid cars sold. So we need to sketch a line for the data. A trend line approximates the balance points above and below the line. The trend line may not pass through any of the data points. I said that already. I'm saying it again. So if you notice, look at my line. Look at my line. I've got 1, 2, 3 below it, 1, 2, 3 above it, and 1 that's kind of on it, but maybe not, a little bit above. So, but the points that it definitely went through, if you look, the bottom point, 250, is definitely a point it went through, and then the other point, it's definitely going through 16,500. If I look through, it kind of looks like 10,300, but it's not dead on, so I wouldn't count it. Anyway, so now that I have 2 points, can I find the line? Yeah. What do? We have 2 points, and we need to write the equation of a line. We got to find the slope. So if I'm finding the slope between 250 and 16,500, you do 500 minus 50 and 16 minus 2 in the denominator, and that's approximately 32.1. Yes, I used a calculator to check it, right? So if I'm approximately 32.1, that's my slope, I still need to find my y-intercept. So use slope-intercept form. Y equals mx plus b. Plug in your y value. Pick either one. I'm going to pick 250 just because they're smaller numbers to multiply by. So I put in 50 for y, 2 for x, and what's my slope? Oh yeah, I just found it. It's 32.1. What do I not know? My unknown is b. So I multiply 32.1 times 2, 64.2. Then I subtract 64.2 from both sides to get my b value of negative 14.2. And now all I got to do is write my line, my equation of my line, my trend line that fits this data. So my trend line that models the data is y equals 32.1x minus 14.2. The trend line is one of many possible trend lines. That is not the only answer. All right. And you'll see that your slope and your y-intercept will be close to the trend line, that whatever answer I give you, it will be close. All right, last, try it. Pause the video. Really pause it. Try to do these. And then when you're done, hit play and just watch. And then you know whether you're right or wrong and fix it if you're wrong. All right, so it says, what trend line in slope-intercept form models the data of the scatter plot? So we need to create the line here and then explain why there could be no data points on the trend line, yet the line still models the data. So I said that answer twice. Pause it and play. So this is the book's answer. The book answered the trend line after they drew it, y equals negative 4/3 x plus 71 1/3 models the data. I'm going to show you my way I did it in a minute. You'll see my math. And then it says B here, explain why there are no data points on the trend line, yet the trend line models the data. So again, because the purpose of a trend line is to model the data, which means the line may or may not pass through any of the given points. All right, that's 3 times you're hearing that. You better remember it now. So now let's talk about my work. If you notice the top, it says Kank's work. I drew a line that I thought modeled the data. Looking at it again, today I made this line yesterday. I'd probably make it a little higher, but that's okay. And you'll see how that changes based on what. So my work is going to come up. This is my entire work. So I picked 2 points. The point that I saw, 268, plot that point. See, I went right through it here. And then 860, I went right through it there. So between those 2 points, I did the math. 60 minus 68 is negative 8. 8 minus 2 is 6. Hey, that reduced to 4/3. If you look, that's the same, negative 4/3 is the same slope they got. So I was like, all right, winning. And then I plugged in the point 268 into the equation, and I got 70 and 2/3. So, and you can even see, like, I did all the math, right? Like, I do the math. So don't think like I'm using a calculator. No, I do the math. So anyway, then my equation here is y equals negative 4/3 x plus 70 and 2/3. Am I really far off? 71 and 1/3 is my y-intercept. I got 70 and 2/3. That's so close. That's 2/3 away. That's 0.6 repeating difference. Who cares? That's close. I got the same slope, but even if that were somewhere around -1, I'd be fine. All right, so that is our lesson. Woohoo, we are done. Yay.